Hello, this is Scott Manley, and I'd like to talk you through this video I created showing the rate of discovery of asteroids for the last 30 years or so, starting in 1980. Now what you see here is a top-down view of the inner solar system with 4 planets in the middle, and on the edges you can see Jupiter. What you also see is a large number of green, yellow and red spots denoting the position of asteroids. The colouring is primarily to indicate how close they can come to the Earth. Green are main belt asteroids, yellow cross the orbit of Mars, and red cross the orbit of Earth. Also, as asteroids are discovered, we flash them white to make them more obvious. Now, if you look in the bottom left, there are 2 numbers. The first is the year, and the second is the number of asteroids known on that date. Now, you can see this number grows as more objects were discovered by astronomers. In addition, the highlighting of the discovery location lets you see patterns in the discovery process. The most obvious pattern is that most objects are being discovered opposite to the direction of the sun. And this of course makes total sense, since you're going to be looking for these things in nighttime skies. Sometimes you see a big flash of discoveries lined up with another planet. Scientists were perhaps looking for new moons around these planets, but found asteroids as well. In the 1980s, most imaging is being done with photographic plates, but by the time the mid-90s roll around, electronic imaging becomes the standard. This gives a significant increase to the discovery rates, since the turnaround time for image processing and analysis gets much faster. When you're trying to discover objects moving across the night sky, it's very important that you follow up on the observations before the object moves too far and is lost. Now, by the late 90s, a number of dedicated asteroid discovery programs are in full flow. These combine electronic imaging with automated image processing and follow-up. Hundreds of new objects are being discovered every day, and new patterns of discovery become evident. If you watch, you can see the discovery rate pulsing roughly twice a second. This corresponds to the lunar cycle. During a full moon, it is harder to discover faint objects since the moonlight makes the background sky brighter. There's also a sparse dead spot around the 5 o'clock position. Apparently this corresponds to the cloudy season in Arizona, where a number of these automated surveys are based. Now, by mid-2000, we're starting to see hundreds of thousands of known objects, and it's getting very crowded in the inner solar system. But you need to appreciate the distances here are huge. 1 pixel at the highest resolution is still 500,000 kilometers. So all those objects apparently buzzing the Earth are still a long way out. And now for a few seconds you're going to see the discovery pattern of WISE, the Wide Field Infrared Survey Explorer. That was a space telescope designed to image the entire sky in infrared. And so we're almost up to the present day, and we have over 500,000 asteroids in our database. I'm Scott Manley.